You can't just turn this telescope toward the sky and see a black hole or something interesting immediately. Usually, we use radio waves to pry on black holes. Because of their own gravity, black holes are some of the brightest things in the sky, and that's because of a very simple construct. All the matter, all the gas and dust is trying to get into a very small region, so it heats up to hundreds of billions of degrees. The supermassive black hole in the center of our galaxy radiates in infrared and radio waves, even a little bit in X-rays. So if you want to look at a black hole, you can come at it from many different angles. Essentially, you are not looking at a black hole, you're looking at its effects on its environment. What we do is we tease around the edges, right? Because of its immense gravity, light orbits it and goes around in a circle. Relativity equations show that you can see this outline of light around the black hole. These are some of the smallest objects in the known universe, right? Black holes are tiny, and to see them you need magnifying power. And as it is with all telescopes, the bigger the telescope, the more magnifying power you have. Now we can't make one huge telescope that sees all the radio waves. So what we do is we install atomic clocks at multiple radio dishes around the world to record data and then play it back at a central facility. And we create a virtual telescope as big as the Earth itself. That's what Event Horizon Telescope has done using data from 8 geographic locations. Each station takes in about 1 million gigabytes of data. And when you stitch together all of these telescopes, you wind up getting a virtual dish that's the size of the Earth. It turns out if you really want to make one of these images, it takes a long time to calibrate the data, and it's all about the details. This is the dawn of new era of black hole astrophysics.